just this. Okay. The first topic is a little background on what we mean by agile methodology. So there's something called the Agile Manifesto. And this was, there's a lot of stuff that has evolved over a number of years, but there was this summit at some point with a lot of people who were central to agile methodologies that got together at a summit, and they drafted this thing called the Agile Manifesto, which is a sort of a short description of what agile development is. And it's on agilemanifesto.org still. It's pretty much the same website as it used to be. And they basically put out these 4 values or credos, which is to understand what it is. The first one is individuals and interactions over processes and tools. Okay, I'm going to put all 4 here and then go through them. Working software, over comprehensive documentation. The third one is customer collaboration over contract negotiation. The fourth one is responding to change over following a plan. So, you probably have to understand the context that this was created in. Previously, most sort of knowledge about how to make big software projects, software methodologies, were based on sort of a different paradigm. Sometimes referred to by these people as the waterfall paradigm, and the idea is that waterfall planning was actually a real methodology that was described in earnest by people, and it's also something that's used for some kind of projects. Maybe not so good for software projects, but it could be useful for other kinds of development projects. And the reason it's called waterfall is that you have this process where you make the project. You start out by having some requirements at one end. So someone, a client or someone who wants some software, and then you work with that person or that institution to figure out what exactly is needed. What do we want to build, and we write some requirements. So that's kind of a specification of what we want to build. And then the next step is we do some analysis on that to find out how should we build it. And then we've analyzed it, we design it, we do some design, and then finally we do some implementation, we write the code, and then we're done. And the reason that's called a waterfall model is because there's information is sort of flowing only this way in that graph. You never go back. You don't go back to requirements once you're done with that. You don't go back to design once you are implementing. So the idea is that you know everything from the beginning about the software, and then it's kind of like a process that's inspired by like building a building or making a movie. If you build a building, then you probably want to draw it first. Make very specific drawings about it before you start pouring the concrete, and this is how software was considered as well. But it wasn't very good, because software isn't like building a building. It's very different from building a building. And this is, as I said, it's very common nowadays in most software shops and places where software is developed. Maybe not always. Sometimes it's only sort of used to the letter, but it's not actually. You still have a lot of these waterfall processes actually happening. But you probably won't find a big big company today that develops software that doesn't use Scrum or equivalent, at least on the paper. But that, as I said, it's one thing to say that you do it. Another thing is actually to adhere by these principles, and that's actually pretty difficult to do because it goes against a lot of the way that companies are organized. So individuals and interactions over processes and tools is a way to say that you really have to think this is a human process. Developing software involves some human beings, and you have to mainly look at who is involved in a project rather than trying to follow a certain process and just fit those people in there, because it doesn't work very well. Working software over comprehensive documentation. I mean, when I started out, I didn't really like writing documentation, but it was something that everyone that was not a hardcore programmer thought was the right thing to do. So you could have some software, but you would also have a lot of documentation, a lot of writing about the software, how it works. And the problem with that kind of thing is that it's not very useful, and it's also extremely difficult to maintain. So what these guys thought was that the best way to show a requirement, what some software is supposed to do, is to actually write the software. It's like the software itself is the best documentation. Customer collaboration over contract negotiation. So that's another aspect which is interesting, because with waterfall projects, you often get this kind of war going on between the customer and the developer, because the customer wants as much for their money as possible, and the developer wants to deliver at as low price as possible, have as little risk as possible. So they are constantly struggling, trying to get the customer wants more functionality, and the developer wants less. And especially in a situation where the process is that the customer should specify upfront exactly what they want the software to do. This is, of course, almost impossible in almost all software projects, because it's very difficult to know upfront what you want. You have to sort of iteratively build it and learn more about it. But the way that these projects are structured, also with the contract, is that the contract the specification list is part of the contract between the customer and the developer. So they pay a certain amount, and then they get these specifications implemented. But then what happens usually is that the customer discovers that they really want something else. They don't exactly want it how they specified it. Then the developer says, well, that's fine, but then you have to pay more, because we already spent the money to develop what you specified. And then you have this war going on about changes. So in agile methodologies, the idea is that you don't actually specify exactly what you want up front. Instead, you involve the customer much more in the process, because the customer or sponsor of the project is usually extremely important to understand exactly what it is that is needed with the software project. And the final thing is responding to change over following a plan. So in agile programming, agile development, you look very differently on the concept of planning. It's not that you say that planning is bad. Planning is a very important activity, but I think there's some famous historic guy who said, it's like a quote from that guy, I don't remember who it was, some Winston Churchill or something, I don't know, but he said that a plan is nothing, planning is everything. And that's very that's how the thinking is here. So planning is something that you do all the time, and you try to not plan the entire project. You do what we call just-in-time planning. So you only plan so much as is needed to have a structured process. Because if you try to plan stuff that's way in the future, like that's something that at the end of the development projects, you know very little about what's going to happen at that time. So you spend a lot of time here planning for that stuff, but there's a huge risk that something will change along the way that will make this plan obsolete, and you have to change it anyway. So responding to change is actually important. Again, if you have these projects that I talked about before that were like these waterfall projects where you had a contract with a specification list at the beginning, and And then you see that once change happens, which happens a lot in software projects, once you discover that you want to change the product, then it's a very heavy process to perform this change, because you have to go back, you have to renegotiate the contract, you have to negotiate about what should the cost be with the client. So any change is seen as a big cost, or is a very sort of hard thing to do. Sometimes you understand that you have to do it, of course, but it's hard to do. And there's even this whole discipline that evolved around that called change management, which is about handling all these changes that happen and figuring out each one. How do we change the specifications, and what will it cost, and stuff like that. But it's a very heavy process. The idea with agile development is to say that change is actually constant. The project changes all the time, so we want change. We want to embrace the change instead of fighting it. That's basically what we say. There's a little bit about in this definition. There is a notion of a team. The team that develops software is sort of inherent in a way. So this team, this development team, is so one point is figures out how to do the work. Some of these things may sound very sort of obvious, but you have to consider that we're talking about like big software projects with money involved and companies and stuff like that, and logical things don't normally happen always. You have a lot of strange things going on. This is also very obvious. The team does the work, but again, it's actually not. Identifies what gets in the way. Takes responsibility to resolve all the difficulties within its scope. Works with other parts. The organizations. To resolve concerns outside their control. The team, we can call it. So it's that's the central actor in this is the team, the development team that actually works on the software. That goes mostly to this first one here. Like this. Yeah, it's just to say a little about what is this team, what is the agile idea of this development team, what does that team do, and there are some important points in there. There's an important point about what we later call self-organization, or like we have a team that's actually empowered to do the work that they're supposed to do. Again, it maybe sounds obvious, but it's not always like that in organizations. So you assign a development team to write some software. You have to give them the freedom to figure out how to do the work themselves, and that's different from how it was done in waterfall projects, where you would have like a big process that needs to be followed, and you have sort of top-down management where the bosses decided how to do the work, and then the workers actually did it. And then there's this point about impediments. Identifies what gets in the way. That's something we call impediments in Scrum. So when you write software, you very often run into difficulties, and that's what saps your time. Basically, it's impediments. It's stuff that stops you from from solving your work. Maybe outside stuff, maybe inside stuff, and this is what the rest is about. Yeah. Okay, let's move on. Oops. No. So the next one is about Scrum. It's a big. What happened there? Just a minute. Yeah, I found this image that is easier to use, so I don't have to draw horrible stuff. Is this one? Yeah. This is a very brief drawing about this agile methodology called Scrum. So Scrum is a very small method. It doesn't contain a lot of rules and artifacts, like a minimal amount, because the idea is that you should put together a team that makes the software, and they should have as much freedom and time to do it as possible. So you don't want to get bogged down in a lot of red tape. But there is a minimal amount of red tape that Scrum creates in order to make sure that you have a forward-moving process all the time. So here you see this word that I mentioned before, the product backlog. The product backlog, the word backlog. Do you understand that? Backlog? It's a backlog is like the list of things that we haven't done yet.
So it's the thing that we presumably want to do.
Yeah. I think it comes from a backlog is like. Yeah. So we simply, instead of specifications, very detailed specifications about exactly how the software works, we have this product backlog, and it has a different name because it should be something else than a specification list. It should be basically only what we know about what we want the software to be. So think of it as a list of sort of generalized items about what we want to achieve with the software, what it should be able to do. Often Scrum projects I've been involved in, the backlog has been expressed in something called user stories. So a user story is kind of like a description of one element of the system and how the user would use that element or perceive that element. So that's like a big list. And then we split up the work into these sprints. We decide on some time frame. It says 1 to 4 week sprints is a normal schedule for sprints. So no longer than 1 month is one rule there is in Scrum. And these projects we're going to do 30-hour sprints, so they are a lot shorter. They're like actually less than a week. And we do the sprint planning. So we start each sprint by looking at the backlog and choosing from the top of that. So the product owner or the people who are the sponsors for the project, they have sort of communicated to us what they want first or what is most important to them. And then the team, they look at that and decide how much can we do in this sprint, or they try to estimate. So they want all this stuff. We only have one sprint. We have to deliver as much as possible in this one sprint, but not more than we can because there's limited time. So we choose from the top of this list and we say these items from the product backlog we can probably do in the sprint. So that's the sprint planning, and all those items that are selected for the sprint, they go into something called the sprint backlog, which is then we look at every time we are in doubt about what to do. And then the sprint starts, Um, you see there's something called daily scrum, so it's like 1 to 4 weeks. There's this kind of an important meeting that you hold every day. They call daily scrum. It's a 15-minute meeting. You usually start every day. If you work like whole days, you start every day by having a daily scrum, but you can have it at other times as well. And the point of the daily scrum is to inspect what is happening. Inspect how far did we get? Is everything going okay? Are there any impediments, any problems that should be resolved? Something that's blocking us from achieving this sprint goal that we have set. And this is how the sprint happens. The rest of the time is completely up to the team. The team is self-organizing, so they decide themselves how to structure the work they're doing. But when the time is up, then you stop and you take a look at what has been done in a sprint review. Usually involve stakeholders, like outside people who are interested in the project, like the client, or and they take a look at all the stuff that has been built during the sprint, and we check that it's the way it's supposed to be. And that's an important big word there, phrase there, potentially shippable product increments. So a very big difference from the waterfall methods is that everything developed in a sprint has to be this potentially shippable product increment. So it means that we have a product, we actually start out with a product. It might be we don't start from scratch on the project, we maybe have a version 1 or something, or we could start from scratch and have like a baseline 0 product. But the sprint is about doing an increment of that product. It's about improving the product, putting some more features in it, changing some of the features, making some improvements to it. So that's why we say increment. And potentially shippable means that the product owner should be able to, if he wants to actually release what was done in this one sprint to the client or to the users. So that's a very big difference from waterfall development, where you actually have to very quickly deliver something that is that works and is finished. So like small increments that are actually finished. Yeah, and then finally you do something called a retrospective, which is also another inspection event, a kind of an empirical event where you try to. It's a good point in time to do an evaluation of the sprint, and this is what you do in the sprint retrospective. Yeah, a little bit more about what is a Scrum team. So I have this anonymous person graphic you can use. Yeah. So, oops. Yeah, so there's a bunch of developers in there. The rule in Scrum is you should have a team of at least 3 people and no more than maybe 9 total or 7 developers. I'm going to call these developers. Yeah, so self-organizing. That is very small. Just a minute. this. Just going to put these words up here now. Cross-functional. No titles. No sub-teams. Whole team. Oops. Always accountable. And then we have two special roles in Scrum, which are also on the team. Yeah, this one is the product owner. And this one is the Scrum Master. Sole responsible for product backlog. Ensures the methodology. Oops. Okay. That's really the only job of the product owner. So there is a specific person, one person assigned to handle the product backlog. So every time stuff changes in that, and that can change a lot during a project, we have this one guy who is in charge of doing that and making sure that the product backlog is available to the team so they know what they should be building all the time. Stuff like that. And that's the product owner who does that. So you can have of course a project can have a lot of stakeholders, like you can have a client with a lot of people, and you can have maybe several different clients or sponsors and stuff like that. That can be like a whole group of people sometimes. But one point of Scrum is that you have to assign the responsibility to one person to manage the product backlog, so it becomes like a coherent goal for the team to steer towards, and not a very sort of diffuse array of requirements. On the other hand, we have the Scrum Master. So that's a person whose sole responsibility is to make sure that all the not so many things, but all the few things that you have to do in Scrum, the rules of Scrum are always kept. The Scrum Master is usually the leader of meetings and is usually the leader of the daily Scrum, and so on. So you always assign that role to one person who has that as a prime responsibility. The workload involved can be different, but that's actually one of the points of this is that you have an average size Scrum team of maybe, if you have like 7 developers, 6-7 developers in a team, then there's probably enough work for like a full-time product owner and a full-time Scrum Master. And that may be a little bit counterintuitive, because that's quite a lot of manpower to use on something which is not development. But this is one of the keystones of Scrum, is that you should really take all that stuff seriously. What the Scrum Master does with most of his time is actually, I mean, there aren't a lot of meetings, but the Scrum Master's main responsibility during most of the project time is actually to work on removing impediments. So any impediments that the developers run into, an impediment is something that stops them from delivering the product backlog, some problem that they can't get around. Well, you have this one guy whose job it is to remove those. And about the team members themselves, self-organization. So this is counter to the way that companies are usually organized, because usually you have a hierarchical organization with some seniors and some bosses and stuff like that. So you have this hierarchy of people who decide stuff, and you're at the bottom of that, you don't decide a lot, and you're at the top of that, you decide a lot. You have all the power. But in a Scrum team, you don't have that. So it might be that some people have more power than others in a team. That's usually like that when human beings work together. You can't avoid that. But there's no fixed roles in a Scrum team. And that's also why it says no titles, no sub-teams. You cannot have that. So the team has to, by itself, amongst themselves, without any outside influence, organize themselves. Who does what? In many cases, there can be people with different skills on the Scrum team. That often makes a lot of sense, because software development isn't just programmers. It's people with different skills usually. It's like testers or documentation writers or graphics artists. It can be many different things. And that's what is meant by cross-functional. So usually you gather a team that's best suited for the job, and that can be people with many different skills. So many of the education you are taking is not a programmer education as such. Some of you are good at programming, and some of you are not so good at programming. But it could be very typical for you with your background to be on a Scrum team. Maybe not as a hardcore programmer, but as a person who does other things, other parts of software development, design the software, for instance.